didn't think about talking about this, but something Joshua said made me think about it. You talked about AI escaping from the box now, and that it often seems counterintuitive to people that you cannot build a really tight box that a sufficiently smart AI cannot escape from. Now, we don't have good intuition for this because we don't have a lot of experience trying to escape from boxes. But all being jealous with boxes which is not physical in nature, like jails, but informational, let us say, jails for software. But we do have a lot more experience trying to break into boxes, however, and trying to extract things from them that should be kept safe in safe boxes. And I think this provides good intuition, good examples. And I'd like to talk about, excuse me, information leakage of various kinds, of information which people try to keep safe, but still have some very restricted way of communicating with the outside world. And a lot of examples come from cryptography. In cryptography, you often have a secret or a private key, which, let us say, a server has, and it wants to decrypt things, it wants to sign things, it wants to participate in, everyday things like SSL sessions, and the key should not escape. People from outside who talk to the server should not learn anything about the private or secret key. And in the last, I'm less familiar with less recent history, but in the last 10 or 20 years, there have been a lot of very interesting attacks, and not just theoretical, but practical achieved attacks on server-side keys, which leak information in all kinds of side channels which people didn't realize were there. And it started by, again, I'm not so much familiar with the history, so I may be mixing up the order here, but there were cases, for instance, where people got to run some other unrelated software on the same physical computer as another program which had a secret key. Now they were unprivileged. It was a separate user, a separate programs, memory space had no direct interaction, but it ran on the same physical CPU. It was time share, obviously, which happens a lot. And it turns out that if you use enough CPU and you monitor the exact times when you get and release the CPU, the exact scheduling of the OS, and you know the exact code that the other process with the secret key is using. For instance, you know that it uses a specific binary version of OpenSSL, and you can expect and compare the code, then you can deduce what the CPU is doing based on, in the other process, based on how much CPU time it uses from microsecond to microsecond. And this actually leaks information about the key because the speed of calculating SSL operations slightly varies depending on the actual value of the key. And so by inspecting exactly how much time the other process uses, every time it has to sign or decrypt something, you can exfiltrate bits of the key, and eventually you learn the entire key in something on the other order of maybe a few hours of runtime, which is a very practical attack. People actually succeeded in doing that. Okay, so you say, fine, I will not let anyone run any other programs on my physical server, fine. Well, except that now it's in this cloud thing when there are VMs, and it turns out you can build an attack that works across VMs that again share the same physical hardware, and people have actually done this, and they've stolen keys from servers lying in the cloud because they got other VMs in other Amazon accounts which happen to be on the same hardware as somebody else. Yeah, but it gets better. Now, suppose you have your own hardware. Now you only communicate over the network. Sorry.